Hey guys, let's keep going with our review. I'm going to pick it up on number 12. So it says to verify the identity algebraically, use the table feature of the graphing utility to check your results numerically. Simplify at each step. So this second part here that says use the table feature of the graphing utility to check your result numerically. I honestly didn't teach you how to do that, and you don't need to, so don't stress about that. So let's see, this left side of the equation, that's what we're starting with. And it looks like they have tried to get a common denominator, so they multiplied by the other denominator. This one we were multiplied by cosine of x minus 1 over cosine of x minus 1. And this is multiplied by cosine of x plus 1. Should put parentheses around this just to be clear here. And then I am multiplying numerator and denominator by cosine of x plus 1. So they got these common denominators, and they already took care of that. We need to fill in the blank in the numerator, which if I distribute the 4, I got a 4 cosine of x minus 4. And this gives me a 4 cosine of x plus 4. So I see the minus 4, I see the plus 4, I see a 4 cosine of x. I think I'm missing one of the 4 cosine of x's. Okay, so that's where they got this from, distributing. And then after that, I noticed that my negative 4 and positive 4 are gone. Like I have no constants here. It's not plus any other constant number. They did combine it all into a single term. And so they did their 4 cosine plus 4 cosine to get an 8 cosine of x. And I think they already took care of the denominator. They did all their distributing. They simplified that down on their own, which is nice. In fact, they then used the identity on their own, cosine squared minus 1 in my Pythagorean identity. So I'll show you what I'm talking about down here. Let's see, all my identities are down here. Yeah, they already used this Pythagorean identity to turn their cosine squared of x minus 1 to turn that into a negative sine squared of x. So they already did that. I'm just going to bring that numerator on down. So the 8 cosine of x still comes. And then let's see, the 8 and the negative, those are taken care of out here. All right. Let's see, the cosine in the numerator, that's already taken care of. Sine squared is sine times sine, that's already taken care of. So I think they took care of pretty much everything, which means I'm just going to say I'm multiplying by 1. And that's like going to make it equal to what I started with. And to check and make sure we got it right, let's see if this simplifies down to their final answer. Their final answer was negative 8 cosecant. So 1 over sine is cosecant. All right, that's good. And then cosine over sine is cotangent. Okay, so yeah, it does get us to where they ended up. Okay, and number 13, very similar. Verify the identity by converting the left side into sines and cosines. All right, so it looks like they already took cotangent and turned it into some sines and cosines. Cotangent is cosine over sine, which again, you can look at the list of identities right here. Cotangent is cosine over sine. All right, so they took care of that. Secant, though, they want it all in terms of sine and cosine. Secant, if I look at my little identity sheet here, secant is 1 over cosine. So I see 1 over, and I have to fill in the cosine of x. Okay, 1 over cosine for secant. And then after that, I see just a sine in the denominator. I don't see this 1 over cosine. So I think personally, I like to write my fractions like this, 2 cosine of x over sine x, and that was all divided by a 1 over cosine of x. So I like to see it that way personally, because then I will, instead of dividing by the fraction, I'll turn it into multiplying by the reciprocal. So I'll multiply by cosine of x over 1 instead. Okay. Which it looks like they've got the sine in the denominator. Good, 1 times sine is sine. The numerator, my numerator, if I multiply that together, is a 2 cosine squared. Okay, so that's where this came from. And then 2 cosine squared of x, if I use that identity, which again, I have it highlighted down here, the Pythagorean identity for cosine squared. If I solve for the cosine squared, I subtract my sine squared over. Cosine squared of u equals 1 minus sine squared of u. So this cosine squared with the 2 in front is going to be 2 times 1 minus sine squared of u, which if you look, it looks like they distributed the 2 because they got a 2, there's your whole number, minus, and then they've got a 2 sine squared. And again, if we did this right, it should get us down to the end here. That would put the 2 over sine, and it would put your 2 sine squared over sine. So you separated that into 2 different fractions. So that's where this came from. And then let's simplify these down. 2 divided by sine is 2 cosecant of x. That's true. And then sine squared, one of these sines will divide out. I have just a 2 sine of x left. All right, so yeah, it looks like we did it correctly. We will end up where they ended up. All right, and then number 14 says to solve the equation. So I'm thinking I'm probably going to start by, oops, not cosine, cosecant x. I'm going to add the 1 over. So I still have the root 2 over 2 coefficient. There's my adding the 1 over. And then I will multiply by 2 over root 2 on both sides. Okay, so I have the cosecant of x equal to 2 over root 2. Now, a lot of us would start simplifying, but I had kind of something trigger my mind here for a sec. 2 over root 2, that is the reciprocal of root 2 over 2. Reciprocal, like I flip the fraction into root 2 over 2. Now, if I do the reciprocal of cosecant, so cosecant is 1 over sine. If I do the reciprocal of that I get sine of x over 1, or just plain sine of x. And again, if you need that identity, that is right down here for my cosecant. Cosecant is 1 over sine. So yeah, again, I did the reciprocal on both sides of the equation, and I ended up with something I think is a little easier to work with. So on my unit circle, I know where my sine is a lot easier than cosecant. Sine is just the y values on my unit circle. And my y values are a root 2 over 2 here at pi fourths, and here at 3 pi fourths. If I go down into the third and fourth quadrant, that would give me some negative sine values, like negative y values. So I think these are the only 2 in one rotation. Now let's see, do they want me to do one rotation? No, I don't think they said from 0 to 2 pi or anything like that. So I'm going to have to consider going around the circle again and again and again, hitting the same points over and over again. So I'm going to do my 3 pi fourths. And if I rotate, I'm going to go like a full circle, full 2 pi n number of times. And then I'm going to do my pi fourths. Same deal, if I go around the circle, I go full 2 pi some n number of times. So that's going to hit those 2 points over and over and over again. So they usually put their 2 pi n first, but whatever, it's the same thing. Okay, and then number 15 looks like I need to start getting the sine squared on its own first. So like I'm going to subtract 5 on both sides and divide by negative 10 on both sides. So I've got a positive 1/2. And now when I take the square root, I need my plus or minus. I'm going to have some positive 1 over root 2's and some negative 1 over root 2's, which I'm going to break this into 2 pieces here. I wrote like this because the sine of 1 is still just 1, and the square root of 1 is just 1, and the square root of 2 I'm leaving as root 2. So I got my positive, and then this is my negative. If I rationalize the denominator, I think what we're more familiar with on the unit circle is a root 2 over 2. If I rationalize the denominator, I get a positive root 2 over 2 and a negative root 2 over 2. All right, so on my unit circle, let's see where we hit those are. Assign my y values of root 2 over 2 here at pi fourths. And then let's see, I get a positive root 2 over 2 again here at 3 pi fourths. And maybe I'll try to color code this for you actually. So let me, this one in blue, all my positive root 2 over 2s. The positive root 2 over 2 is at pi fourths and 3 pi fourths. My negative root 2 over 2, I'm going to try to, like I said, color code this a little bit for you. Negative root 2 over 2, my negative y values are down here in the third and fourth quadrant. So this is at 5 pi fourths and 7 pi fourths. These all look like they're going the same distance between these solutions. So it looks like there is like a 90-degree angle, it's like pi halves between those guys and another pi halves and another pi halves. It's the same distance between each of my solutions. So usually we'll start at, you know how we usually start at the positive x-axis and we start rotating this way. The first one I hit was the pi fourths, so maybe I'll start with the pi fourths. So I've got pi fourths and then every pi halves after that. So pi halves n is going to hit every next solution. So there's my final answer. I think they again put their pi halves n, they put that first, but that's fine. Okay, and then number 16 says to solve the equation and enter your answer as a comma separated list. Use n as an integer constant and enter your response in radians. Okay, so I did notice these are both signs, which makes things much easier when they're the same trig functions. That's nice. I think I'm going to try to minimize this down as best I can. I'm going to divide everything by 6. That gets me to 2 sine squared 3 sine of x plus 1 equals 0. Okay, so you've got a couple options here. You can do quadratic formula or you can do factoring. I think my class usually says they want to do factoring, so I will stick with that. In this case, I would do factor by grouping because of that leading coefficient of 2. So I will do 2 times 1 is 2. So what multiplies to be 2 and adds up to 3? Okay, multiplying to be 2, add up to 3. I think I'm going with a 2 and a 1. 2 times 1 is 2, 2 plus 1 is 3. Good, so I'm going to use my factor by grouping. I'm going to break my 3 sine of x. I'm going to break it up into, we chose a 2 and a 1, right? So I'm going to break it up into a 2 sine of x and a 1 sine of x. Okay. And the whole point is to do some grouping. I'm going to group the first 2 together, and out of that first group, their GCF, their greatest common factor, is 2 sine of x. I'm still left with another sine and a 1. All right, and then in my second group, I think there's not much they have in common. I can always factor out a 1, but besides that, I don't think there's anything else they have in common. So my GCF, my greatest common factor, is just a 1. I'm left with sine of x plus 1. All right, so now what they have in common is the sine of x plus 1. So I will factor out their GCF, their greatest common factor, sine of x plus 1, and I am left with a 2 sine x plus 1. Okay, so at this point, I'm going to set each of my factors equal to 0. So I'm going to scroll over here a bit. One of my factors was sine of x plus 1. That's going to be equal to 0. My other factor was 2 sine of x plus 1 equals 0. So it looks like if I'm solving for sine of x is a negative 1, and sine of x is a negative 1/2. Okay, so on my unit circle, let's see where my sine, my y values are going to hit a negative 1 and a negative 1/2. All right, so first things first, sine or my y values are negative 1 down here at 3 pi halves. And again, maybe I'll try to color code this again. All right, so a negative 1 down here at 3 pi halves. To make my sine be a negative 1/2, Assign my y values. I've got negative y values down here, so I'm going to get a negative 1/2 y value here at 7 pi 6, and over here at 11 pi 6. Okay. And let's see, am I going to be able to go the same distance every time to hit these? No, I think I've got a much longer, and then I've got a shorter and shorter distance. So I think what I'm going to do is separate this into 3 different pieces. So for the 3 pi halves, let's see, where am I going to put this? Actually, I think they already wrote it for us. So for my 3 pi halves, they've got this whole 3 pi halves. I've got it in green here. 3 pi halves, and they're going around every 2 pi, every full circle. They're going to hit the 3 pi halves. And then my 7 pi 6, it looks like they've got that over here. My 7 pi 6 plus 2 pi n. So go around the circle and hit your 7 pi 6 again and again and again. And then the 11 pi 6, again, plus 2 pi n. 2 pi is a full circle, so again, it's like they're going around a full circle, hitting the same point over and over and over again. All right, so there are the solutions, and we got it off of our unit circle. Okay, let's go to number 17. Find all solutions of the equation in the interval 0 to 2 pi. Okay, so this one, if we are going specifically from 0 to 2 pi, like one rotation around the unit circle, I'm not going to have any more that like the ends that I had on the previous problem. Those are going to be gone. It's just going to be like the one solution that I got in my unit circle. Okay, so let's see here. Find all solutions of the equation in the interval 0 to 2 pi. Enter your answers as a comma separated list. If there's no solution, then you answer no solution. Okay, this one does not have the same trig function. In fact, I've got a tangent squared and then a secant of x minus 1. All right, so let's look at our identities and see if there's anything we can use. Honestly, for me, as soon as I saw tangent squared, usually when I have any of my trig functions squared, I can probably use one of the Pythagorean identities. Whether it's the most useful or not, that's not always the case, but it's an option. Let's look at that option here. So my 1 plus tangent squared equals secant squared. So if I solve for just the tangent squared, if I subtract the 1 over, tangent squared of u equals secant squared of u minus 1. And so let's see, that actually kind of matches the other trig function on the other side. That means everything would be in secants. So yeah, I think I'm going to use that trig identity. I'm going to turn it into secant squared of, I don't have a u, I have x in this case. So secant squared of x minus 1. All right, equals secant of x minus 1. All right, if I add 1 to both sides, the minus 1s are gone. All right, and so I'm going to show you what the mistake is that I usually see on this kind. A lot of times I see people divide by secant on both sides, which is not the way to approach this. When I divide by a variable, in this case it's an x, dividing by this secant of x kind of eliminates some of my solutions. So I'll show you, this is my what not to do, okay? I'm going to show you over here what I should do. I should make this all equal to 0. I'm going to subtract my secant on both sides. And then I will factor out a secant of x. That's what they have in common. And then I will set each of my factors equal to 0. Now, if I had factored them out, I would have gotten to secant of x equals 1. So I kind of would have, oops, this one was off by negative. There we go. Okay, so I would have got what this equation does, secant of x equals 1, but I would have been missing this whole other solution set over here. So for that reason, I need to make sure that I do this method where I factor. I don't want to divide by variables. All right, so I have let's see, I've got two equations here I need to find on my unit circle. Okay, so secant. Secant is the reciprocal of cosine, right? So if I do, instead of secant, if I want cosine, I have to do the reciprocal. I have to do like, if I'm treating it like 0 over 1, I would treat it into like 1 over 0 for the reciprocal, which 1 over 0 is undefined. There is no 1 over 0 x value on my unit circle. So this actually is not going to give me a solution. And then secant of x, again, if I do the reciprocal, I get a cosine of x. Instead of 1 over 1, if I do the reciprocal, I get another 1 over 1. So I'm basically looking for my cosine to be a 1 on my unit circle. If the x value is a positive 1, it looks like I will be right here at, now, should I call it this 0 or should I call it the 2 pi? Let's see, they've got a square bracket on the 0. They're including the 0. They've got the parentheses on the 2 pi. They are not including the 2 pi. So I will not include 2 pi. I'm just going to call that straight up 0 radians. And that's the only point that I have. So that's why our only answer here in this case is 0. All right. So on number 18, I'm going to solve for x. It says solve the multiple angle equation. Enter your answer as a comma separated list. They did not on this one. They didn't tell me what I highlighted on the previous one. They didn't say from 0 to 2 pi. So if I'm not restricted from 0 to 2 pi, I'm going to want all the solutions. I'm going to have to say like plus, they have an 8 pi n, but I'm going to have to use the n here. So let's see. I think I'm going to start by subtracting a root 3 on both sides. And I'm going to divide by 2 on both sides. All right, we've got a negative root 3 over 2. And I actually know on my unit circle where I get a negative root 3 over 2. Sine are y values. So I will get negative y values in quadrants 3 and 4. And it looks like that would be these two right here. Okay. Which that looks like 4 pi thirds and 5 pi thirds. There we go. Okay. Now, if this was straight up sine of x over 4, then great, those would be my x's. But this is not sine of x, this is sine of x over 4. So I'm going to set my x over 4 equal to the 4 pi thirds, and I'm going to set my x over 4 equal to the 5 pi thirds. So if I solve for the x, if I multiply by 4 on both sides, it looks like the first solution is going to be 16 pi over 3. And this next solution, again, if I multiply by 4 on both sides, I get a 20 pi over 3. Okay, so that's where they came up with these. Now, how do we know that they're adding a 2 pi n? Or sorry, they're adding an 8 pi n instead of 2 pi n. We're used to going around the full circle like 2 pi, but they have an 8 pi. So here's how that happens. I usually put, like I said, I usually put a plus 2 pi n, but I'm multiplying everything by 4. This also is, squeezing this in here, it's multiplied by 4, so my 2 times 4 is 8. That's where we get this plus 8 pi n on both of them. So 16 pi thirds plus 8 pi n and 20 pi thirds plus 8 pi n. All right, and then number 19 here, solve the equation. And I'm noticing that I've got two different trig functions. I got a secant and a tangent. But I'm thinking, first of all, I saw secant squared. I'm thinking Pythagorean for that. Also, secant and tangent are in the same Pythagorean identity, so I think I'm going to go with this same one I had at the bottom here. I'm going to rearrange it to solve for secant squared, so I'm going to use the highlighted part here. Secant squared is equal to 1 plus tangent squared. And I've got tangent squared of x in this case. I know it said a u on the identity, but my variable is an x on number 19 here. And then I've got plus 7 tangent x equals 9. Okay. So I think this is going to kind of put me back to, where were we at here? Yeah, I think it's going to get us back to like number 16, where you're going to have to like factor and, okay, so tangent, come on, there we go, tangent squared of x plus my 7 tangent of x, and I'm going to subtract the 9 over, so 1 minus 9 is a negative 8. So as far as factoring goes, I do not have a leading coefficient on this, so I don't have to do the factor by grouping. Let's see if we can figure out what multiplies to be negative 8 and adds up to 7. So out of all my options, 2 and 4, 1 and 8, I think I'm going to go with a positive 8 and a negative 1. Okay, so we factored it, and let's set each of our factors equal to 0. I already solved on this one. I added the 1 over. I'm going to do the same thing here. The first one, I'm going to subtract the 8 to the other side. All right. And then let's see here. On my unit circle, I do know where tangent can be a positive 1 on my unit circle. Tangent is sine over cosine. So whenever my sine and my cosine, like my y and my x, are the exact same numbers, they will divide out to be a 1. So I'm thinking probably at pi fourths. That's the point root 2 over 2, root 2 over 2. They're the same x and y, so if I divide them, I get 1. At 3 pi fourths, though, I've got a negative root 2 over 2 and a positive root 2 over 2. If I divide those, I'm going to get a negative 1. This does not say it equals negative 1. It's supposed to equal a positive 1. So that's why I was going for root 2 and a positive root 2 over 2. They're both the same here. This is at, like I said, pi fourths. Radians. My 3 pi fourths, though, this one's out. I'll deal with this in a sec here. This point is negative root 2 over 2 and another negative root 2 over 2. Okay, that's looking good. Negatives divide that to be a positive 1. And this one is a positive root 2 over 2 and a negative root 2 over 2. Which again, they divide into a negative 1. So for that reason, I'm going to go with my first quadrant, so pi fourths, and my third quadrant, so 5 pi fourths. And then I'm not going to use the ones that divide out to be a negative 1. Okay, so let's see, I found a pi fourths and a 5 pi fourths, which I can rotate half a circle. I can go pi radians, and then I can go another pi radians to hit the next point, and I can go around and around and around by a half circle each time. So again, usually I start at like 0 radians and I rotate. Okay, and the first thing I hit was at pi fourths. So I'm going to start with pi fourths. Some green actually. I'll start with pi fourths, and then I will add pi some n number of times. Okay, so those are my green solutions here. That's like my second equation. The first equation, though, tangent of x equals a negative 8. I actually don't know where that is on my unit circle. So I can't use one of the, radians that I memorized. I'm going to have to do an inverse tangent of negative 8. That solves for my x there. All right, now, let's see if I can show you this. It's gonna work on there. That's not gonna work, so I'll do it this way. All right, so what I'm gonna do is my tangent, we should know on our graph of tangent, it repeats the same thing over and over and over again. This has to do with the period of the function. And this repeats every pi halves, or sorry, every 1 pi. So that's the period for tangent, which is why they've made us add pi times n. So personally, here's how I would write it. Tangent inverse of -8 plus pi n. Like it's going to repeat every pi. Now, they kind of used one of their identities here. Let me see if we can find the identity. Here we go. They used the fact that tangent of some negative number, in our case it was tangent of -8, you can say negative tangent of the +8. So that's how they wrote it here. Honestly, they're both totally the same. If you want to leave it like that, that works as well. So here were the two solutions that I had from the two separate factors that we set equal to 0. Okay. And then on to number 20. Find the exact values of sine, cosine, and tangent of this angle. Now this angle, 13 pi over 12, that is not an angle that we memorized on the unit circle. So I think I'm gonna have to break this down into two other angles, either being added or subtracted. So let's see, I'm probably going with these sum and difference identities, things that I can add or subtract to a 13 pi 12ths. Let's see, I could do 12 plus 1 is 13, but I don't know what 1 pi over 12 is. I don't have that on my unit circle. All right, so let's see. I can do a 1 plus 12. I can do a 2 plus 11, but again, 11 pi 12ths, it doesn't reduce to something that I have on my unit circle. I'm kind of thinking about this 13. My 1 plus 12, my 2 plus 11, that didn't work. 3 plus 10, well, 3 12ths, again, does not reduce down. Let's see, 4 ninths, 4 and 9. I think that'll work actually, because 4 pi 12ths and 9 pi 12ths, both of these fractions are going to reduce. So I think I'm going to go in this direction here. Honestly, there are so many different ways you can do this. If you chose a different way to do it, that doesn't mean it's wrong. We should end up with the same answer though. So I'm going to reduce these fractions down to, let's see, 4 12ths is a third, so pi thirds. 9 12ths, let's see, that reduces, they're both divisible by 3, so I'm going to get 3 pi fourths. Okay, so these are actually points that we have on our unit circle. We should have them memorized. All right, so my pi thirds, oops, there we go. There's my pi thirds, my 3 pi fourths over here in the second quadrant. All right, and once we know their xy points, so I'm gonna get rid of these real quick. This would be 1/2 and root 3 over 2 at pi thirds, and then at 3 pi fourths, I've got negative root 2 over 2, positive root 2 over 2. All right, since I have those memorized from my unit circle, I'm going to use them in this identity. So let's see. We're going to have to do two things added together, right? There's a big plus sign right here. So I'm going to do, for my sine of 13 pi 12ths, I'm going to do sine of pi thirds plus 3 pi fourths. All right, so that is this guy right here in my identity sheet. All right, so sine of u, which is sine of pi thirds, times cosine of u, so cosine of 3 pi fourths, plus cosine of u, so cosine of pi thirds, sine of v, so sine of 3 pi fourths. Okay, sine being the y value. So my sine of pi thirds, the y value of pi thirds is root 3 over 2. Cosine of 3 pi fourths, so the x value at 3 pi fourths was a negative root 2 over 2. All right, and then cosine of pi thirds, so the x value at pi thirds was 1/2. And sine of 3 pi fourths, the y value at 3 pi fourths was root 2 over 2. All right, so this gets me to a denominator, a common denominator of 4. So it's over here. common denominator 4. This first one has root 3 times a negative root 2, so a negative root 6. And then I've got, oops, the second one that I'm adding here is a root 2 times 1, so just a root 2. All right, so here's my answer. Now, don't freak out. I know they wrote their answer differently. You should be able to put them into the calculator, and they should give you the same decimal form. Just because I wrote it in a different way doesn't mean it can't be correct. So like if somebody said, 2/4 and somebody said a half, like they're totally equal to each other. One of them is considered simplified and one of them is not, but they are equal to each other. Actually, what I have over here is the simplified answer, and because it does not have a square root in the denominator, what they put as their answer does have a square root in the denominator, so they actually didn't do the simplified answer. What we have is the simplified answer here. All right, let's look at, now they want cosine. I'm going to do cosine of pi thirds 3 pi fourths. Okay, so here is my cosine identity down here where I'm adding stuff up. That gives me the cosine of u, so cosine of pi thirds, and the cosine of v, so cosine of 3 pi fourths, minus sine of u, so sine of pi thirds, and sine of v, so sine of 3 pi fourths. Okay, and again, we should be able to get these off of our unit circle. Cosine of pi thirds being half, cosine of 3 pi fourths being negative root 2 over 2, minus sine of pi thirds, so root 3 over 2, sine of 3 pi fourths, so a positive root 2 over 2. All right, looks like they are both going to have a denominator of 4 again. 2 times 2 is 4 on both of them. So there's their common denominator. The numerator, though, is going to be a 1 times negative root 2, so negative root 2. And then looks like we have minus the root 3 times root 2, so a root 6. Again, it may look a little different than the answer that they had, but it should, decimal-wise, come out to be the exact same thing. All right, and then last but not least here, we're going to do the tangent of pi thirds plus 3 pi fourths. All right, so this one's a messy fraction. That's fine though. Tangent of u, the u being pi thirds, plus tangent of v, so tangent of 3 pi fourths, over 1 minus each of these tangents. Okay, so tangent is the y value over the x value. So at pi thirds, it's going to be a root 3 over 2 divided by a 1/2. That's just the tangent of pi thirds. Then we've got to do plus the tangent of 3 pi fourths, which that one actually turns out a bit better. My y divided by x, that'll simplify down a bit more. Okay, divided by, and then I've got 1 minus each of those same messy fractions. Plus multiplied by. Okay. So very messy at the beginning, but we do have some simplifying to do here. Let's see. If I simplify this down, these are both in halves, so it's kind of just turning into a root 3. And this second fraction here, root 2 over 2 divided by a negative root 2 over 2, it's very messy, but it's the same number divided by itself, just off by a negative. So it ends up being a negative 1. Okay, so then same thing here. This is like a root 3 and a negative 1. Root 3 times negative 1 is a negative root 3, and I have to subtract my negative root 3, so I'm ending up with plus root 3. Okay, so let's see. Did they write theirs that way? Oh, they wrote it in a different way, but it should be equal to what we started with. Okay, I actually did not have the simplified answer. Theirs actually is a simplified answer in this case. They do not have us dividing by any square roots here, so theirs is actually simplified. All of these will be marked as correct though. Okay, and then here we go. All right, so last one for this video is number 21 here. It's pretty much the same thing we were just doing. It's just in terms of degrees, and it's a negative angle, negative 105 degrees. So I need to find things that I can either add or subtract to get a negative 105. And not just anything though, I need some angles on my unit circle that I've memorized that I could either add or subtract to be a negative 105. So, okay, I think the 5 is kind of triggering my head here. I probably have to use like the 45 degrees or like a 135, something that ends in a 5. The rest of them, most of them end in a 0. You've got your 30, 60, 90, you've got 180, you've got a lot of them that end in zeros. I'm probably going to have to use one of these that ends in a 5. All right, so let me see here. I'm thinking maybe it'll be, let's see, maybe I go with a 45. Sure. If I start at negative 45, it gets like, say like even more negative. I need another negative number here. So what if I subtract like 60? Okay, that works. 45 and 60, those are memorized ones on the unit circle. So I think I'm gonna stick with it this way. Negative 45 degrees and then minus a positive 60 degrees. Okay, I am gonna have to, like I said, consider negative 45 degrees here on my unit circle. Negative means I go clockwise. So my negative 45 degrees is going to end up right here with the xy point root 2 over 2 and a negative root 2 over 2. Actually, let me get this out of the way a little bit and I'll put it up here. Again, my negative 45 degrees, 2 over 2, and a negative root 2 over 2. Okay. The positive 60 degrees, that is up here in the first quadrant. This is what we actually used on the previous problem. I've got a 1/2 and a root 3 over 2. Positive 60 degrees. Okay. So out of all my identities I've got down here, I think the sine of 105, I'm going to have to do, like I said, with subtraction. I'm going to go with this guy that I circled. I've got to do sine of negative 45 degrees minus the 60 degrees. So I've got this sine and they're being subtracted. So that's why I know I'm in this category. The u is the negative 45 degrees and the v is the 60 degrees. So I get sine of negative 45 degrees, cosine of 60 degrees, and then minus, let's scoot this over here. All right, cosine of u, so cosine of negative 45 degrees, sine of v, so sine of 60 degrees. All right, which means I've got sine of negative 45, like the y value here at the negative 45 is a negative root 2 over 2. Cosine at the positive 60 is a 1/2 minus cosine of the negative 45 degrees, so positive root 2 over 2, and sine of 60, the y value root 3 over 2. Okay, so again, these have common denominators already, which is nice. So I can say this is all a denominator of 4. The first one here, if I do a root 2, negative root 2 times 1, I get a negative root 2 minus my root 2 times root 3, so a root 6. All right, and again, that doesn't look exactly like the answer they gave us, but if you put them in the calculator, they should decimal-wise be the exact same number. So you can write it in a different form, and they will both of these would be marked as correct. Okay, next up, I've got, let's see here. I got to do the cosine. All right, so my cosine of negative 45 degrees minus 60 degrees. Here's my cosine identity of stuff subtracted. So that's going to be cosine of the u, so cosine of the negative 45, and cosine of v, so cosine of 60 degrees. I think the mistake I usually see on this is people think this is a negative 60. The negative itself is in the identity. Cosine of u minus v. So the negative right here is already taken care of. The v itself, what I'm subtracting, is a positive 60. So make sure your v, in this case, is a positive 60. All right, and I'm going to keep going with the identity here. Sine of u, v. Okay, so cosine of 45 of negative root, cosine of negative 45 degrees is our x value positive root 2 over 2. And the cosine of 60 degrees is a 1/2 plus sine of the negative 45 degrees, so a negative root 2 over 2 times sine of 60, so a root 3 over 2. And again, nice common denominators of 4, so I can go ahead and add these fractions with the denominator 4. I get a root 2 minus root 6. So it looks a little different, but it should decimal-wise be the same answer. All right, and then the last one is the tangent. Okay, so here is this tangent of u minus v identity. Okay, so I've got to do a messy little fraction here. I've got tangent of u, so tangent of the negative 45 degrees, minus tangent of v, so minus tangent of 60 degrees, over 1 plus the tangent of u, so the tangent of negative 45, tangent of v, so tangent of 60. Okay, so tangent of negative 45, like if I did my y over x, negative root 2 over 2 divided by a positive root 2 over 2, negative and positive are the same number divided out to be a negative 1. All right, and then tangent of 60 degrees. So up here, I have to do my y over x again. So it would be like a root 3 over 2 divided by 1/2. Again, the 2's divide out, so it's like a root 3 over 1. It ends up being just like a plain root 3. Then I've got the same ones down here. Tangent of negative 45 is what I got before. It's a negative 1. And tangent of 60 is the same thing that I had up in the numerator. It is my root 3 over 1, or just root 3. Which means this will simplify down to negative 1 plus root 3 over 1 minus root 3. Okay, again, this is not the simplified answer, but it will be marked as correct. The answer they had is actually the simplified answer. You should be able to put them in the calculator and get the same decimal though. All right, I hope this helps, and I'll see you guys later.